Suppose that we know that Z naught is a pole of order m of f of z, and we'd like to determine the residue. How can we do that? Well, we've already seen one way to do it involves just looking at the Laurent series. All right, if my function is given in terms of functions like sine or cosine or e to the something, all right, which have easy Taylor series that we can manipulate in an easy way, then we might just appeal to the Laurent series. All right, however, there's also a formula that we can use. So, since f has a pole of order m at Z naught, I could say right, the residue is C sub negative 1. Okay? So that means that I could get at this residue by taking derivatives of a function. But I'm going to need to first make this function regular or analytic at Z naught. So I'm going to begin by multiplying this function by Z minus Z naught to the m. So here I've got Z minus Z naught to the m minus 2. C negative 1 is the coefficient of Z minus Z naught to the m minus 1. And then we've got the rest of them. If I want to get at C sub negative 1, I need to get rid of all of these pieces, all right, and try to isolate this C sub negative 1. If I take Z equals Z naught, it's going to get rid of all of these terms that give me C sub negative m. Okay? What if I took a derivative first? Well, if I take a derivative, that gets rid of that one. It gets rid of this factor. And now if I take the limit as Z approaches Z naught, all the rest of these terms will still have minus Z naught. So they'll go to 0. So if I take a derivative and then do the limit as Z approaches Z naught, then that will isolate C sub negative m minus 1. If I were to take two derivatives and then take the limit as Z approached Z naught, the two derivatives would cause this and that to vacate the premises. All right? And so I would have C sub negative m minus 2 times a constant. It wouldn't have any more z minus z naughts, but all the rest of the terms would. So they're all going to go to 0. So if you think about this, you should be able to convince yourself that if I want this coefficient, then I need to take m minus 1 derivatives. I had to take m minus 1 derivatives. All of these terms are going to go to 0. They're already 0. Here, I take m minus 1 derivatives, and I'll get m minus 1 factorial, c sub negative 1, and I won't have any dependence on z in that term. So the limit as z approaches z naught does not affect this term. All of these terms have more than m minus 1 factors of z minus z naught. Each derivative gets rid of one factor. But that means that I have at least one factor of z minus z naught left after taking the derivatives. So as z approaches z naught, all of those terms in the infinite series will go to 0. This gives us a formula for the residue. It's 1 over m minus 1 factorial, limit as z approaches z naught, m minus 1 derivatives, just like that. All right, and that's going to be our residue formula.